Welcome you all for this polymer science class for GATE 2023. The first class will be on basic features of the polymer conformation, configuration, and calculation of polymer chain in twin distance. Now, before going into any detail, let us first understand what do we mean by polymer. Now, polymer, the name itself is composed of two aspects. One is poly, another is mar. Now poly means many and mar means chemical unit. So the name itself implies that polymers are composed of many chemical units which are called monomers. Monomers. Now mono means single. So single chemical unit, they together compose polymers. Now how this composition takes place? The single chemical units, or what we call it as a monomers, they are bound together with the help of covalent bonds. Now we have three types of primary bonds. One is the ionic bond, another one is the covalent bond, and third one is the coordinate covalent bond. Now for the formation of the polymers, only covalent bond is active. The reason is the covalent bonds on individual basis are much stronger than ionic bond. That is, if you compare 1:1, a covalent bond is stronger than ionic bond. Covalent bond is directional, whereas ionic bond is not. Coordinate covalent bond, if you consider that why coordinate covalent bond is not active in forming the polymer. Now coordinate covalent bond is a special case where an atom donates a group of electron to another atom, means it's a donor acceptor system. Now when you are binding similar or slightly dissimilar chemical units together, then how can you have that aspect fulfilled, that the donor acceptor system is working? So that way we have these covalent bonds that are active or that is functional in forming the bonds between the monomer units. Now, as the name implies that it is composed of many chemical units or monomers, it means that these are not small molecules. So these are what we call it as a macromolecules. Now macromolecules means giant molecules. Now there are so many macromolecules available in nature or that are being chemically synthesized. Now the question is, all macromolecules are polymers? And the answer is no. Why? Because in order to be a polymer, it should establish that covalent bonds between the monomers, or what we call it as the repeating units. So once that condition is satisfied, only then we can call a macromolecule is polymer. So any macromolecule cannot be polymer. So we can say that polymers are macromolecules, but all macromolecules are not polymers. Now, when we have such kind of macromolecules which are very dissimilar in nature from other earthly materials like our conventional solids, liquids, and gases, because neither of these are macromolecules. These are composed of small units and small similar units. But polymer, these are not composed of small units, but these are composed of, means these are composed of by the combination of the smaller units together. So in that way, polymers, or these macromolecular polymers, you can say, these are different from these conventional materials. Now, how scientifically we can address this difference? There is a dimensionless number, what we call it as a Deborah number. which is expressed as relaxation time by observation time. Now lambda is the relaxation time and t is the observation time. Now what do we mean by this observation time and relaxation time? Observation time or experimental time is that the time through which some stress is applied on a material, and lambda is the relaxation time, means when that stress is withdrawn, then how much time the material takes to relax. So the ratio is a dimensionless parameter because both are having their dimensions of time, and this forms a dimensionless number called Deborah number. Now this Deborah number is a very characteristic feature for all sorts of materials that we can see around us, for solids, for liquids, for gases. Now this Deborah number actually is what we can say is a very important feature to distinguish a polymeric material from all these earthly material. That this Deborah number for polymeric material is always greater than 1. That is, whenever some stress is being applied, let it be a mechanical stress or any other form of stress, it could be also electrical stress, magnetic stress, whatever. So when some stress is being applied and that stress is withdrawn, then the polymeric material will take higher time to relax, that is to respond. So that makes that lambda greater than t, that is this Deborah number becomes greater than 1. Now if you consider an elastic solid, its